Now we have Amruta with us from Castin by Venom, and she will be talking on application-aware backups of Kubernetes application, where she will be focusing on two open source tools, that is Kanister and Kopia, to optimize backup and recovery from Kubernetes application.
Yeah. Hello, everyone. So as the title says, I'll be talking about taking effective backups of Kubernetes applications. Quick introduction, I am Amruta. I work as a member of technical staff at Castin by Veeam. We, as a team, focus there on finding solutions for data management problems. I am heavily contributing Kanister, and I'm pretty new to open source as well. So what are the different types of data management? Firstly, typically a cloud-native app consists of a database, persistent volume, and different Kubernetes resources that can manage those databases, and different resources as well. So one of the ways to actually protect the application is to take storage-centric snapshots. Storage-centric snapshots are actually provided by underlying file or block storage. They are typically crash consistent and fastest way to protect the data. But the problem with these kind of storage-centric snapshots is that it does not talk to the application or database. So the application or database is not aware of the snapshot being taken, which makes it inconsistent. In this case, the second type of data management approach is effective, where we actually make API calls to the application or database and tell them that to freeze or flush the data whenever the snapshot is being taken, then take the snapshot, and then you can unfreeze the data. The third type of data management approach is that we actually use the data service specific tools, that is MySQL, examples like MySQL, pgdump, and etc., which will take the backup of the data. In this case, there is a database level consistency that is achieved, and this type of data is actually out of band and which can be restored in different type of storages. Restores over here are relatively complex. Yeah. So considering all these approaches have different pros and cons when it comes to speed, consistency, and cost as well. Typically, a cloud-native application have different types of owners, and each of the owners actually have different type of requirement when it comes to protecting different parts of the application. Some of them may need logical backup, some of them may need volume snapshots, some of the database may reside on maybe example Amazon RDS, so we may need to make Amazon specific calls. So, and all these needs need to be addressed. They cannot be ignored. Some of the applications may need to scale down the application, and some of the applications may need that the storage object store that is needed where the data should be uploaded is different. So different type of object storage should also be supported. So this leads to typically a complex workflow that needs to be developed to protect an application. That's why we need a data protection tool which needs to have these goals. Firstly, it should be application-centric, that is the business continuity of the application should be intact. The application should be running while the data is being backed up. Backup is, of course, easy as we have seen in the approaches, but restore also needs to be easy. There could be certain compliance requirements by the users, that the number of snapshots that are being taken that should be noted to the users, and there should be minimum requirement of the snapshots. The utmost important need, you can say, of the data protection tool is it should be secure and reliable. So it should provide some sort of authentication authorization for the people who can take snapshots or who can modify the snapshots. The tool should also provide end-to-end encryption while it is being backed up, also while it is being transferred to some external store, which may protect it from the disaster. It should also have efficient storage, that is, it should take less storage space while storing the data as well as while transferring the data. Also, the protection tool should have different type of backend storages where it can upload the data. So do we have such tool? Yes, we can have it in a combination of two open source tools. One is Kanister, other is Kopia. Let's take a look at what these tools are. Kanister is an open source tool which helps us take application level backup of the Kubernetes applications. It is a controller. It's based on operator framework, and it actually manages lifecycle of different CRs, which helps us take backup and restore of the application. We'll take a look at the CRs in the upcoming slides. Kopia, on the other hand, actually manages the backed up data that the Kanister takes on the remote storage. So you can say that Kopia is an open source tool which manages file system snapshots on the remote storage. It is secure and reliable. That is, the data that is being backed up is end-to-end encrypted, and data verification is also available. The data that is being backed up is immutable. That is, someone cannot go and change it or delete it. There is an efficient transfer and storage, which means there is a content-based data duplication. That is what Kopia provides, which means if a particular content is already uploaded, it will not upload it again on the next backups. There's compression also available in Kopia. It uses less memory, and it also supports a lot of backup targets, backend storage targets. Okay, so the main three terms that we'll be talking in demo as well is related to Kopia is Kopia server, Kopia client, and Kopia repository. Kopia repository is nothing but the backend storage where we are going to upload the data. So in Kopia, it is called as Kopia repository. It is protected by password and a user. So at a time, only one user can access it, apart from the credentials that are used to connect to the backend storage. Kopia repository server is something that manages these repositories, and it allows proxy access to the underlying storage, which means the clients that are going to connect to the backend storage, they need not have the information of what credentials they need to connect to the backend storage. They just need to connect to the Kopia repository server, and Kopia repository server is going to handle the upload and download of the data. So let's talk about the framework, Kanister framework components that we have. We have a couple of controllers over here, Kanister controller and repository server controller. Kanister controller manages a different set of CRs, that is blueprints and action sets, and repository server controller manages the lifecycle of repository server CR. So what exactly is blueprint? Blueprint is a specification where you can define the workflow of what operations needs to be performed to backup or restore the data. It's a static file, you can say, that you can add to XCD, but to run this static file, we need something called as action sets, which triggers an action that is written in the blueprint to do the operation on the database. So that is an action set CR. And to push this data to remote repository, we need repository server CR, which has the configurations that are required to start the repository server. So the repository server controller would listen to the events on repository server CR, and then will start the Kopia repository server. Apart from these components, there are two more CLIs that are given by Kanister framework. One is CanCTL, which helps us to create these CRs, also validate the CRDs. There's also CanDo, which will be used to push and pull data from the object store. All right, let's take a look at the example blueprint. So I'm going to show you a blueprint related to backing up MongoDB. So if you can look at the spec, it is formed of multiple actions. Each action corresponds to multiple database operations. Each action has multiple phases, and each phase actually makes use of a Kanister function. So what exactly is Kanister function over here? Kanister function tells how we are going to perform these operations. For example, here kubetask is used. Kubetask actually creates a pod and execute these operations on that particular pod. So if you need if your logic need is to have, scale down an application, you can use another function that is written in Kanister, which is scale workload. So there are multiple functions that are already available, which we can use in the blueprints to do different tasks. So when this particular action is actually executed, the blueprint creates an artifact which is a reference that can be used by the next action, that is restore and delete. So in this case, whenever the backup is created, we need a snapshot ID that would be used by the restore action later on to get the data from that restore ID. Let's take a look at the example repository server. To start the repository server controller, we need certain secrets. Secrets which are required to start the repository server successfully. Two of them are credential secrets. Since I'm demoing AWS S3, these credentials are stored in two different secrets. As I said, repository is protected by password and username. At a time, one user can connect to the repository, so it also needs to be provided to the repository server controller. The path where the data would be uploaded. To start the repository server controller, we need admin credentials, so that also needs to be provided as a secret. The client communication, that the Kopia clients that need to be connected to the Kopia repository server needs to have a certain SSL connection, so those secrets are also passed to the repository server as a TLS secret. As I said, that the Kopia has an authorization mechanism where it tells that only these set of users can access the Kopia repository server. So these set of users are uploaded or added to Kopia repository server as a secret, and only the clients can only connect using these users to the repository server. All right. So for an example action set, if you see, action set is used to trigger an action in the blueprint. So if you look at the spec, it is going to call the backup action from the MongoDB blueprint that we saw, and it is going to execute that action on the MongoDB replica set. It also needs the repository server details. That's why this is also added to the spec. Once this action is executed, the status is stored in the status field by the Kanister controller along with the artifact. So here the ID of the snapshot is shown. All right, let's get some demo done. I hope I'm audible. All right. So since I am demoing backup of MySQL application, let me show you that MySQL is installed. Okay, MySQL is already running. We are going to create backup of this. Kanister is also installed. Kanister operator has repository server controller and Kanister controller, both of them running. Let's add some data into the application. I'm creating a test database. All right, so the data is there. Now let's create a repository server so that the blueprint can connect to it. So for that, we need certain secrets to be created. So let's create that as well. All right, let me show you what happens. Okay. So once we create the repository server, it creates a pod and service for the repository server by the controller. So if we see, the pod is running and there should be a service also created. Yeah. So once the repository service is running, let's see that. if it's in ready state. The server needs to be in ready state before we perform the next action. So it tries to connect to the backend repository RC user, so it takes a couple of seconds. So let's wait for that. Meanwhile, we can create the blueprint that would be doing the backup. All right. I think it should be in a ready state. Okay, yeah, it's in ready state. Let's create an action set. As I said, action set is used to trigger one of the actions of the blueprint. The action set will be triggering backup action of this particular blueprint on this particular stateful set, and would be using the Kopia repository server that we just created. So let's see, the backup is running. Okay, it's completed and it has generated a snapshot ID for Kopia. Let's try to delete some data to see that it can get restored in the next action. All right, test is deleted. Let's try to create the restore action set now. It needs to know from where it should get the backup ID from. So we are going to provide this particular backup ID. All right, I think the backup is complete. We can probably see that the database is created again, and we can check the data as well. Yeah, so this is done. So we can see that the data was backed up and restored successfully. Let's get back to demo. All right, if you look at the workflow that we did currently, was we created a repository server which will create a pod and a service for the Kopia repository server. Once that is running, we pass that reference to an action set. Action set tried to find the blueprint from where it is going to create the action. It executed the action, backed up the DB, and actually uploaded the data using the repository server. I missed to show you probably the blueprint. Let me show you the blueprint as well. Yeah. So if you look at the blueprint over here, it actually uses the MySQL dump command and uses can do location push, which uses the repository server to push the data. So that is how the blueprint looks. All right. The future improvements that we have currently in this code is currently whenever the repository server pod is created, and if anything goes wrong, all the logs are propagated to Kanister controller, and repository server controller. So if you want to see particular error, it should be available in the repository server pod. So the next improvement would be to stream whatever errors are coming in the Kopia to the repository server pod. Also, we are going to support creation of repository server CR and secrets. Since there are a lot of secrets, it would be difficult to remember schema for each of the secrets. So we want to provide support for that as well. We want to write multiple Kopia-based blueprints for different set of databases. And also, we are going to provide metrics for Kanister controller and repository server controller, in the sense that number of backups taken, number of restores done, number of action sets created. So that would be available on Prometheus as well. All right. You can connect to us on Kanister, Slack, visit Kanister GitHub, and start contributing to it as well. All right. Any questions? Yeah. We do have blueprints right now, but those are not Kopia based. We are directly connecting to the object store and pushing the data. So yeah, we are going to write blueprints which are based on Kopia. No, not yet. We are into development phase. We have completed one phase of development, so we will be moving forward as well. Yes. You can write blueprint in the way you want to write. Whatever operations you want to perform, you can write in the functions that are available, or you can extend the Kanister code as well to implement more functions and add more functions according to your requirements. Yes, correct. Any more questions? Thank you.
Thank you, Amruta, for this insightful session. And we have some gift for you. Just wait for a minute. Till that, if anyone want to present their views or express themselves, like how were the tracks, how were the speakers, the sessions, all the things. Anyone? Okay, any particular question on this session? Yeah, so now I will request Divya to felicitate. Okay.